Okay, hello everybody. My name is Aida. I'm an Android engineer at Clarity Money. First of all, I would like to congratulate all of you because you have just won the opportunity to listen to the first-time speaker. So congrats on that. Now let's get started to actual talk. As many of you heard or know, Kotlin was named the breakout project at OSCON conference, and it's also the fastest growing language on GitHub. And it's not surprising. With such a rich standard library, Kotlin removes so many obstacles we Android developers have faced working with Java. Most of the developers already taking advantage of sealed classes, extension functions, inline functions, etc. In this presentation, I'll be talking about delegation, delegated properties in Kotlin. It's something new that Java developers not aware about, and how to incorporate them into your custom views and make your views a little bit more reactive. So the origin of delegation comes from object composition, which allows to combine simple objects to make a complex one. The delegation is kind of alternative to inheritance. It means you can use object of one class inside another class and then forward the calls, messages to that class, and it's called delegate. Delegation is better than inheritance because it makes you think what messages you're forwarding because you know the class, the instance of the class, rather than having a new class. And it also does not require you to accept all the methods from your superclass. You can provide the methods that only make sense. It also can be viewed as a mutual relationship between one object that forwarding call to another object. And the most primary advantage of delegation is runtime flexibility. Your delegated class, delegatee, I call it, can be changed at any time during the runtime. There are two types of delegation, explicit and implicit. Explicit delegation, every language has support for explicit delegation. You can pass one object as a parameter or use it as a variable inside another class. When it comes to implicit delegation, you will need some support from your language. Let me refresh some knowledge. Let's say we would like to build a room that has door and windows. We would start with creating interfaces for window and door classes. In this example, I chose the actions window action, like open window and close window, and then door actions, close door and open door. And then door and window classes will implement appropriate interfaces, basically methods from appropriate interfaces. Then you would create a room class that implements both interfaces, and upon overriding the methods, you would tell your, for instance, close door method, you would forward this method to your door class, saying door.close door. And as you see, window class and door class, there are like helper methods, we call them delegate, in your room class. So you would do the same for other methods from your interfaces. The things get more interesting when you want to introduce another class, which is living room class. Technically, living room is a subclass of the room, obviously, but in many apartments nowadays, living room doesn't have a door. Therefore, you can still extend the room class, but then you would expose methods like close door and open door, which are not part of the living room. So that's where inheritance actually falls apart, and you would use the delegation. Here in the living room, we have a class implementing methods from window listener and then window class as a delegate that takes care of the implemented methods. The delegation pattern builds mutual relationship between classes, and that's why it's flexible and a powerful mechanism. Unfortunately, explicit delegation requires so much effort to write methods that literally forward the methods to your helper objects. And because explicit delegation very verbose in Java, a lot of languages have implicit support, like out-of-box support, including Kotlin. Let's say if we want to rewrite these room classes and living room classes in Kotlin, we would still need to introduce interfaces for window and door classes, and then have those window door classes implement the interfaces. as shown above. Then upon creating room and living room classes, use simple keyword by to define a delegate. In the room example, we're letting window class to handle all the methods from window listener, and the door class to handle all the methods from door listener. And in the example with the living room, you're telling window class to handle all the methods from window action listener. By delegating those methods to your delegated classes, our class, like room and living room, is more focused on main functionality. Implicit delegation is a powerful feature that allows you to extend class functionality easily and conveniently. You don't need to implement methods from interfaces manually since the compiler does it for you. This is a Java code of classroom generated by compiler. Looks just like original Java code I showed earlier, minus the naming, property naming. And if you're in Android Studio, you can go to the Tools, Kotlin, Show Bytecode. Wait a minute, what is it? Okay, here we go. So you can go to the Tools, Kotlin, Show Kotlin Bytecode, and click on Decompile button. It will display your Kotlin class in the Java. Basically, it tells you how Kotlin code compiles down. Okay, these animations. Kotlin also has property delegation, support for property delegation. It is similar to class delegation. Let's say we have a user class with the first and last names. Then somewhere in activity, we have a property user that delegates of its get and set values to another object. In our case, it is instance of user delegate class. User delegate is a custom delegated property class. Under the hood, the compiler creates a hidden helper object initialized with the instance of user delegate to which the initial property the user delegates to. In this example, using the by keyword, we're delegating the getters and setters to user delegate class. You have two options to make delegated property: implementing interface or using operator with set and get values. If you want to make immutable property, you would implement read-only property interface. For mutable ones, you need to implement read and write property interfaces. And also, basically any object that has get value and set value with operator keyword, as it's shown above, can be used as a delegated property as long as you have proper references to the property. And if you want to make an immutable one, like val, for instance, you have to have at least get value. You don't need to have set value for that. And as you see, there's no interface needed. Both functions needs to be marked with the operator, the keyword operator. It is important because when it comes down to compiling, there's a special set of parameters that determine where and to which property the delegate can serve. Now, let's look at the built-in delegated properties provided by Kotlin standard library. The first and probably the most famous one is a lazy delegate. How many people have used lazy word in an Android project? So, yep. And maybe not many of you know this is a delegated property, but it is delegated property according to the description. So the idea behind lazy delegate is that sometimes we want to initialize object only when it's first time accessed. Okay, it's doing the animation, cool. But we want to share it is initialized only once and only when first accessed. And for other subsequent calls upon get value, the remembered value will be returned. Simply put, this delegate can suspend object creation until first accessed. This is really important when you're working with heavy objects, like creating database instance or Dagger components or all other parts of the logic that heavily depend on these instances. With lazy delegate, the result is remembered, as I said earlier, and the same value is returned on subsequent calls of get value. When creating lazy delegate, we use byLazy keywords, and the code in Lambda executes only when someone refers to this property for the first time. So let's say when inside the About Me fragment, when we call component that get view model or anything like that upon on create or on pause, that's when it's going to be initialized for the first time. Also, we should define as lazy all the elements that depend on lazy initialized elements. Like for instance, here we have a view model object. We have to define view model object lazy as well because it depends on the component object that has been initialized lazily already. Otherwise, the attempt to construct view model object will take place during the class creation when we cannot yet read the values from component. And it wouldn't be able to fulfill the component property, therefore application will crash. Lazy works with read-only properties. As you see, it's a val component, val view model by lazy. Thanks to that, we have all the benefits of thread synchronization and smart cast. There are three types of thread synchronization. The default one is the synchronized one, when evaluation of the initializer block happens in one thread and all other threads see the same value. But, here we go. So yeah, the second one is a publication one. Publication thread mode means many threads can actually have access to the initializer block. They can initialize the lazy property, but only the first one will return as a value to all other threads. So regardless how many threads will initialize the lazy property, whoever did it first, whichever thread did it first, will return the value every time when someone refers to the lazy property. And there is a third one is a none. So when you have no any kind of locks, and this init block can be accessed from all the different threads. But then again, the behavior is undefined, so you never know what value will be returned. Some of the benefits of lazy. First of all, it's a faster class initialization that leads to faster application startup time because value initialization is delayed until it's first accessed. These properties are non-nullable, so it prevents a lot of null check for us. Since read-only properties can be lazily initialized, we have all the benefits of smart cast and thread sync. Some values may never be used. Therefore, we're saving resources, memory, battery, because it will be marked by compiler. In Java example, in Java implementation, the set values will still be remembered as a usage, will be noticed as a usage by compiler. The property is declared and initialized in a single place, so therefore the code is concise. And we can extract the lazy delegated property into extensions and solve a lot of Android problems like find view by ID or binding colors, binding strings, and other parts of logic and model. Lazy delegate is pretty simple, pretty straightforward, and easy to start working with. The second one is not null delegate. It allows us to define a delegate to be not nullable and initialize at a later time, not during the object construction. We can define variable to be non-nullable without providing a default value. It is alternative to late init variable with one exception. Late init variable is a little faster, so it should always be used. But you cannot use late init variable for primitive or top-level properties. Like in this example, you cannot use late init for integers because it will give you an error, compiler error. And for this kind of cases, you have to use not null. And when you try to access the not null delegate before setting a value, you would get illegal state exception instead of Kotlin null pointer exception that usually the late init throws at you. And obviously an application will gonna crash. So have to keep it always in mind that you have to set value before first attempt of usage. Not null delegate gives us advantage of being initialized later, not during the class creation, and prevents a lot of non-necessary null checks. And it's in general a great alternative to late init when it comes down to primitive and top-level properties. The third one is map. Map is a very convenient tool to parse data and that has key and value structures. The standard library comes with extensions for map and mutable map with a string key type that provides get and set value functions. Thanks to them, map can also be used as a property delegate. Map key type needs to be string, while value can be anything, so it's not restricted. Let me give you an example of map delegated property. So let's say we have a class profile that we pass map to, and inside the profile class we have properties first name, last name, phone number, or income. And using keyword by, assign map key to class property. In this example, we're letting first name to delegate to the map. Then somewhere in your calling class, or it can be API, you can create a map or receive a map that contains all the values and provide it to your class. In this example, we have our map has also middle name, but in our profile class, we don't have a middle name, so we don't need to care about middle name. One thing to note is that the keys in the map should match your names of the properties in your class. So delegating fields to map can be useful, for example, when we have object from API with dynamic fields. We would like to treat the provided data as an object to have easier access to the values, but we also want to keep it as a map just in case to be able to list all the fields given by API, even the ones that we're not expecting. By delegating to map, we define a structure that is telling us what kind of keys we should expect. It also simplifies the access to the values in the map. So instead of doing map, square brackets, name of the key, find value, like that's how you find value. Instead of that, you can use just the profile, that first name. It's easier to use it. The fourth one is observable. Kotlin provides some custom implementations of delegated properties for us to use. One example is observable property that mimics all the basic functionality of read and write property, but also has a callback function when the property is changed. The coolest part of this delegated property is that callback function passes old and new values of the property. And as you might imagine, this can be very useful in applications because it's a much cleaner alternative to callbacks, to regular callbacks. So, delegated observable, you can make any property to be delegated observable by passing the keywords by delegate observable, as you might have guessed. Then you would pass the initial value. In this example, this is a property Boolean, so we're passing initial value to be false, and we're passing the Lambda function. Lambda function takes arguments like P as a reference to the property, old as a previous value of the property, and new as a new value of the property. And then Lambda function will be invoked each time when a new value is set to the property. Let's say we click on a button and change isLoading to be true. Buttons get disabled and progress bar is visible. And once we get the response from update profile method, we change isLoading to be false, and that enables buttons back on. The biggest problem that can be solved using observable delegate is that in list adapters, there's always been a problem with NotifyDataSetChange that has to be called every time when the elements in a list changed. In Java, the classic solution was to encapsulate that list and call NotifyDataSetChange in each function that modifying the list. In Kotlin, so if you auto-translate the function from Java to Kotlin, you would end up with this method where you call again NotifyDataSetChange after the setting values to the list. This might work, but Kotlin provides better solution with Delegated Observable that passes old and new values of the property. It is particularly important to remember that Lambda function called each time when a new value is set, not when the inner state is changed. For instance, when the new list comes in, it will notify about changes. But if you add a new item inside the list, the callback will not get fired. The observable delegate is used to define behavior that should happen on the property value change. It is most frequently used when we have operations that should be done every time when we change a property, or when we want to bind a property value with a view or some other values. But inside the function, we cannot decide whether to set a new value or not. And for that case, we have a vetable delegate. Vetable. So it's the last built-in delegated property. The vetable function works similar as an observable delegate with two main differences. The lambda from argument is called before a new value is set, and it allows the lambda function from declaration to decide whether the new value should be accepted or rejected. Therefore, lambda should return Boolean that has to be true or false. So basically, vetable can be used to establish a restriction on setting a value. For instance, we have a list adapter that takes maximum 5 elements. In Java way, we would introduce a method that checks if new list contains 5 elements or less. If so, then we would set the new value to the list and then notify about changes. In Kotlin, we can use vetable and check if new value meets our requirements. If it does, the value for list will get updated and the value will be set. Otherwise, the old value will take a precedence. Let's suppose that we want to have our list bounded to view. We don't want to allow any changes that will make it possible to have more elements than 5. We update the adapter only if number of items in the list 5 or less. We're using NotifyDataSetChange. Another great example of vetable usage is validation. In this example, let's say we would like to accept names that starts with A. Like if you have a contact list and you're listing the names starting with A. And as a simple validation, we can use the length of the word. If it's empty, most likely it means user did not enter anything, so there's no need to validate. If user types in very long name, very long first name, we might want to show an error and say, hey, this is not the valid name. Maybe you need to shorten a little bit. Otherwise, the name is valid. And you would still check if the name actually starts with A. This delegate is a great way to either set reasonable bounds on a value or implement simple validation framework. Vetable is useful when we don't want to make any changes to the property for some other reasons. We might be loading data. It also comes with other benefits from Delegated Observable, like having access to old value and partially updating UI. Okay, now we're going to get a little bit more practical. Theory has passed already. When developing apps, we often find ourselves replacing one icon with another icon to reflect. Is it updating? No. Okay. To reflect a change of state, a new available action. For example, the product team comes up with a requirement saying, hey, we would like to let the user to like a social post or send a comment to the post. And it all depends whether user inputted anything to text field or not. So the most naive approach and very fast one that most people do is to come up with 2 buttons and play with the visibility. And you would check if upon text watcher, if the text is changed, then you would set the visibilities of 2 buttons. And then inside the onClick listener, you would have your methods like post or send comments based on the buttons. The second approach is to change the background resource of one button and introduce a variable to keep track of the user's input so that, like, let's say you have a variable is input empty that checks, and if it's empty, upon on-click listener, you would call one endpoint, and if it's not empty, then you would call the other endpoint called send comment. Later, when you look at the design, you will see the same functionality has been used in other screens, so you would end up making a custom view. Oh, okay, custom view. And initialize with some cool animations and have variable that tracks down if the post is liked or not, if the red heart is shown or not. Then you would have two methods, public methods like show like and show send, to display the status of the button by checking the value of show like. And then here in Morph, you do some cool animation, change it from red heart to send icon, from send icon to red heart. And then in your calling class, you would set the methods in your text watcher. Like if the number of characters is 0, most likely you need to display the red heart. And if it's 1 or more, you would display the send icon with the cool animations. Then, but the question rises upon clicking on the button, what to do if like post and send comment are different endpoints, so you need to incorporate something here, some kind of logic to be able to call different endpoints. The simplest solution is to expose the variable from your custom view and make it open. Then in your calling class, in your on-click listener, you would do something like that. If button is show like, then we're gonna like post, otherwise we're gonna send comment. Now ask yourself, what if user like the post, send comments, and we wanna give the opportunity to unlike the post, which happen to be, again, different endpoint or something else. Here we're adding the third property, and we need to display, again, the cool animation with the gray heart, or like from red heart to gray heart and anything like that. So we're adding the third property. In our custom class, we would introduce this property saying is liked as a Boolean as well too. And we would have the method saying, hey, if it's liked, then maybe we would like to change our animation from red heart to gray heart and vice versa. Or like send icons from gray heart to send icon, etc. And then after getting information from social post, let's assume that get post is a response from our backend, and it returns the post object. Inside the post object, there is a property called isLiked, and we can pass that value to our button in our setLiked view. Then we would have nested checks of button animation state, as well as a data information, either inside onClick listener, or you can put it as a separate method inside your custom the custom button. Here, for example, here when you have when button like is liked, and also button like is show liked, then you're gonna unlike. Otherwise, you would check if it's liked, then you're gonna send comment or not. So pretty much a lot of nested checks happening with UI animation state and also the data information that you have about the button state. This might be okay. This will work, obviously, but let's find a better way to create more enticing experience with observable delegate. Sealed classes are a great way to encapsulate the state of UI that we would like to see it. So in this button so far we have 3 states: show liked, show unliked, and send comment. Back to our custom view. Here we have declared our custom animations that visually indicate the state of the button. And there is by keyword, which means these properties are delegated properties, and the get and set values are being passed to BindAnimation. And BindAnimation is an extension method of the view, and it's also lazily initialized. So it is the method that is responsible to make a cool animations using animated vector drawable create. And then the fun part begins here when we introduce a state variable as an observable delegate. We pass initial value. In our case, it's gray heart, so we said it's going to be unliked. And then inside the Lambda function, we perform our operations. If a new value is send comment, but old value is a show unliked, therefore, I guess we have to make an animation from gray heart to the send icon. And if it was liked, then we would display animation from red heart to the send icon. And then you would fulfill all the states with associated previous values, or use only new values. It's up to you. How would you like to use it? In this example, I specifically used all the new values, so it's easier to understand. Yeah, I'm almost there. Easier to understand why this is a preferable option to use for custom views. Then in our calling activity, we need to change the state of the button. I have combined the API response status, which is basically returns the get post from our backend, and it has the field is liked, and combined with edit text interactions into one observable. Ideally, this chunk of code should be in a view model, so you pass all your edit text observable text changes into your view model, and only result, the button case, will be returned, and upon subscribe, the value will be set to the button. And here, as you see, we return the B function that checks if the number of characters in our edit text more than 0, then we will change this to the send comment. And otherwise, if it's liked, we will display show liked. Else, we display show unliked. Now, thanks to the sealed class, we have access to the button state. And upon performing click, we can check and make appropriate calls. And most importantly, avoid nested checks. This is a custom view in full, looks like this, pretty clean and straightforward. Yep. Next one. Now we're gonna talk about a little bit more complex case that involves a popular MVI pattern. When you have multiple views that depend on each other and have complex animation views, MVI has drawbacks that require some enhancement. In this example, you can imagine how many fields there are how many user input fields. Every view basically is a user input field, and some of like employment status and occupation, they're animated views, therefore they get generated, added to the view group only after user chose something. In short, the idea behind MVI is that there could be multiple intents coming from database, from user interactions, from services, but UI, in our case, that one view group consumes only one type of UI model with the properties that needs to be inside our view. Most of the times, there are also extra properties to indicate the next UI action, like, hey, dismiss dialog intent, or show loading. When you have the dynamic fields that depend on the result of your previous intent, and you want to incorporate like animated views, you would end up introducing many other properties like show animated view 1, show animated view 2, etc., like 3, 4, depends how heavy your view is on user interaction. And inside your reducer B function, this part of the code usually lives in a view model. You would set the values of these show animated views on every intent because user actions are not predictable, so you don't know where exactly user will do actions. You don't know when the intents will get fired. Therefore, in order not to display some of the animations or like add animated views, you would manually set the animated views on every intent. Like in this example, if employment status is chosen, then we would display animated view to be true. But if date of birth clicked, we're not going to display animated view to be false. As you see, this becomes a little bit more verbose and heavy to keep track of that. Then in your calling activity, you would combine all user intents into one observable, or you can pass it as a separate observables and send it to your view model. Then observe all the changes and render the view every time new value of UI model comes in, even if some properties of UI model has not been changed from previous intent. With delegated property, we can define our UI model as a delegate observable and pass initial values of our UI model from view model, calling like view model.initialState callable.call, And in Lambda function, determine whether we want to render our views again and animate them or not. For instance, if first name of previous value does not equal to the first name of new value, then you would set the text. Otherwise, you don't need to redraw the view again and then redraw the text on that view. And if previous employment status was empty and new one is not, then we can add occupation by animating the view. Okay. While the same functionality can be achieved in different way, the clarity and reusability of observable property has a huge advantage when developing custom views. Not only data bound to UI can be notified of changes immediately, observable, delegate, and viewable can partially update UI for you and also reduce the boilerplate, and avoid code duplication. And in general forces you to write a cleaner code. This was in no way exhaustive overview of delegated properties and what can they do in your custom views. I encourage all of you to play with it, explore it, and see where it can lead you. Thank you very much for your time. And if you have questions, just stop by me, ask anything you would like.